Hassan. Today my presentation topic is electrochemical machining. These are the contents for my presentation. That is introduction, why use electrochemical machining, principle, working procedure, chemical process, main equipments, applications, and advantage, disadvantages. As my presentation topic is electrochemical machining, first I'm going to introduce with what is machining. Machining is one of the manufacturing process by which excess material is removed by shearing from a preformed blank in the form of chips using cutting tools in order to get a desired shape and finish. So machining is mainly the work of removing metals. Now, what is electrochemical machining? Electrochemical machining is the process in which electrochemical process is used to remove materials uh, from the workpiece. So we can say that the machining process is mainly material removal process. So here are some of the types of material removal process. These are conventional machining, which is turning operation, drilling operation, milling operation, and milling operation, etc. And abrasive process like grinding process, and non-traditional machining process like uh, mechanical energy process, electrochemical machining, thermal energy process. So electrochemical machining is a non-traditional machining process. We have too many conventional machining processes, but why we need to use a non-conventional machining process? Here I am trying to find out some of the reason behind this. We know that the tool must be at least 30% harder than the workpiece in conventional method, but in electrochemical machining process, tool is not necessary to be harder than the workpiece. In electrochemical machining, it is easy to handle materials, hard materials as well as the soft materials. Uh, drilling drilling of hard and brittle material in conventional process can break the workpiece, but it is very easy to produce hole in electrochemical machining. Complex contours and cavity can be machined easily in electrochemical process. The working principle of electrochemical machining is based on Faraday's law of electrolysis. The weight of the substance produced during electrolysis process is directly proportional to the current flow to the length of the time and the equivalent weight of the material. So when two dissimilar metals are in contact with electrolyte, the anode loses the material to cathode. So the workpiece is work as an anode. This is a graphical representation of electrochemical machining. Here we can see the workpiece. Here, this is the workpiece, which is basically an anode, and this is the electrolysis electrolyte flower, and this is the tool, which is act as a cathode. I'm going to describe the process of working process in 4 steps. At first step, uh, here this is the workpiece, which is the anode, and this is mainly the tool which act as a cathode. The workpiece to be machined is connected to the positive pole, and the tool is connected to the negative pole. And there is some electrolyte flow uh, who connects the workpiece and the cathode. In second step, an aqueous electrolyte solution, here is the solution, is between the gap of electrode and the workpiece, which connects both the workpiece and the cathode. The electrolyte carries the ions needed for the process, dissipating and generated heat and discharging dissolved materials. So and the next step, the anode proceed to the workpiece, and the workpiece is machined as the shape of the cathode. So the workpiece contour is created through the guided movement of the tool, and after that the cathode is removed. That means the workpiece is removed, and it can be used for the next machining process. Here is a uh, video to describe the process easily. This is electrolytic machine. Here it is the workpiece, and this is the cutting tool. Workpiece is in a positive pole, and the tool is in negative pole. So the workpiece uh, dissipates the positive ion, and it removes the material from the workpiece. So here there is no touch between the workpiece and the cutting tool. The chemistry of the process. For describe the chemistry of the process, I am considering the machining of low carbon steel, which is primarily ferrous alloy. For electrochemical machining of steel, generally a natural salt, that means sodium chloride solution, is taken as the electrolyte. The electrolyte, that means sodium chloride and water, dissipates like sodium chloride as sodium plus ion and chloride ion, and water as hydrogen ion and hydroxyl ion. When the potential difference is applied between the workpiece, that means the anode, and the tool, the positive ions move towards the tool, and the negative ions moves towards the workpiece. So that hydrogen ions will take two electron and in the tool, and create hydrogen gas. Similarly, the positive ion, that means ferrous ion, will come out from the workpiece and takes two electron from the electrolyte, and um, it reacts with the chloride ion. So here you can see the chloride ion and iron ion will create ferrous chloride. The cathode and anode reaction are shown here. Now I am going to describe the main equipments of the electrochemical machine. Main equipments are power supply, electrolyte supply and cleaning system, the tool and the tool feed system, the workpiece and work holding system. For power supply, a high voltage direct current, basically as high as 40,000 ampere, and uh, a low value of electric potential across the inter-electrode gap is desirable. The highest current density achieved for so far 20,000 ampere per centimeter square. With the help of rectifier and transformer, three-phase AC current is converted into low voltage high current DC current. Voltage regulation of 1% is adequate for most of the precision ECM works. The next equipment is electrolyte supply and cleaning system. For electrolyte supply and cleaning system, it consists of pump, filter, control valve, heating and cooling coil, pressure gauge, and storage tank which stores electrolyte. A small intercooler inter-electrode gap, usually smaller than 1 millimeter, should be maintained for achieving high accuracy. Smooth flow of electrolyte should be maintained, and any blockade of such a small gap by particles carried by electrolyte should be avoided. It should be ensured that piping system does not introduce any foreign material like corroded particles, scales, etc. The next equipment is tool and tool fit system. Use of anti-corrosive material for tool and fixtures is important because they are required for a long period of time to operate in a corrosive environment of electrolyte. Um, Aluminium, brass, bronze, copper, carbon, stainless steel are few materials which are used for this purpose. Tools are not tools are on the ECM. Action is not required. Should be The tools should be insulated. Um, Use of a non-corrosive and electrically non-conducting material for making fixture is recommended. The next equipment is a workpiece and work holding system. Only electrically conductive material can be machined by this process. The chemical properties of anode material like uh, the working the properties of anode material largely govern the material removal rate. Work holding devices made of electrical materials having good thermal stability and low moisture absorption properties. Graphite fibers, reinforced plastics are materials used for fabricating and work holding devices. These are the applications of ECM. We can apply this process in automotive, turbine technology, pharmaceutical industries, mechanical engineering, steam turbines, marine technology, and so on. Um, Advantages of ECM. ECM can machine highly complicated and curved surfaces in a single pass. A single tool can be used for machine a large number of pieces without any loss. Machinability of work material is independent of physical and mechanical properties. The process is capable of machining metals and alloys irrespective of their strength and hardness. Machined surface are stress and bar free, having good surface finish. There is no thermal damage, and a bar free surface can be produced. These are the disadvantages. This equipment is highly capital cost of equipment. Designed and tooling system is very complex. Hydrogen liberation at the tool surface may cause hydrogen embrittlement of the surface. The spark damage may become sometimes problematic. Non-conductive material cannot be machined. Blind holes cannot be machined in solid block on a stage. Corrosion and rust of ECM machine can be hazard. Space and floor area requirement are so higher than conventional machining process. So that's all. Thank you, sir.